So a percentile in a data set is a data value where some given percent of the data is below the value. And we've worked with percentiles a little bit. For example, the median is also the 50th percentile. It's the data value where 50% of the data is at or below that point. We would abbreviate that as P50. We looked at quartiles. Quartile 1, the first quartile, is also the 25th percentile. It's the point in the data set where about 25% of the data is at or below that point. It's abbreviated P25. And with percentiles, we can go two different ways. We can look at a data set and find out which value marks where the 25th percentile is, or we could go the other way. Given a value, what percentile does this value represent? Now that can be a little tricky because sometimes there's repeated numbers in a data set going the other way. But we can find any percentile we want. For example, we could find the 10th percentile. So the 10th percentile would be the place where 10% of the data is before that point. And usually we say it's at or before that point. Let's try this on a data set. So we did that About You survey where I asked a whole bunch of different questions, one of which was the hours of sleep per night. So I just want to kind of play around with this right here. Just stick this. So again, I have the hours, usual hours of sleep per night. I sorted it. This is what the histogram looks like. And looking at the histogram, I have one person that's out here in the fringe, but it looks like a relatively symmetric bell shape. And let's see, what's the center here? According to the mean, it's about 7 hours. And according to the median, it's about 7 hours. And usually when a data set is symmetric, the mean and the median will be equal or very close. And here we can see the mean and the median are very close to each other. So this data is relatively symmetric, although it looks like it has a slight tail on the right. So we'd say this data is slightly right skewed. As far as percentiles go, we have some here. So the Q1 is a 6. So that's one of the 6s in this list is the point at which 25% of the data is at or before that point. Now here's where it gets complicated in a data set where numbers are repeated a lot. Which of these 6s here is the one that marks that 25%? And there's a whole bunch of 6s. And here you can see I made a note that around the 59th number here in the list is the point at which 25% of the numbers are below that. So this particular 6, whoever that one belongs to from this sorted version, is the first quartile. We could take a look and do some percentiles, like I mentioned, the 10th percentile, so P10. There's the quartile command, there is the percentile command, and I recommend the percentile inclusive, like we use the quartile inclusive. And the percentile command wants to know a couple of things. It wants to know where's your data. I would select my data is in column A. It's only going to look at the numbers in there. And then it wants to know which percentile I want, and the percentile is going to be given as a decimal. So the 10th percentile would be 0.1, 1/10. And it's going to say, so that one of the 5s represents the 10th percentile. And oops, I can see I've got a whole bunch of 5s. If I wanted to identify which one it was, then I have to do a little bit more work and find the position of the 5th, of the 10th percentile. Similarly, I could find what's the 90th percentile for this data. So 90. again, the command is percentile, and percentile on most spreadsheets works the same as percentile inclusive. We rarely have a use for percentile and exclusive, so let's not go over that. So again, just select your data and tell it which percentile you want as a decimal. So this is 0.9 for the 90th percentile. And the computer says, well, the number 8. And again, in this data set, because it's hours of sleep, there's probably going to be many 8s. And so one of the 8s in this list is that particular one. In data sets where there's more variability in the numbers, then the percentile might be a unique value in the data set. But usually it's going to be a value, say, between two numbers. It's not going to be a perfect fit in the particular case. Next, suppose we believe that this hours of sleep is normally distributed. Then we can use our mean and standard deviation to estimate the mean and standard deviation of the population. So based on this, let's say for the population of students, average hours of sleep per night is around 7, with a standard deviation of about 1.3. Then we can answer other percentile questions based on that. Just going to go over to Desmos to play with that. We'll set the mean to be about 7, the standard deviation to be 1.3. And then I just want to play around with the raw. Steal this into my whiteboard. Check back here to do some calculations. So add to page, please. So this here is a normal distribution. For hours of sleep per night for BMCC students. And I'm using my sample to estimate the population. And in my estimates, I'm saying my mean is about 0.7 hours per night, and the standard deviation I'm saying is about 1.3. So then the center of my distribution should be 7, and we can see the scale lines up. In StatKey, the scale is not always going to match the numbers you're working with, but the scale will be accurate in its own way. Now, if I go 1.3 to the right, that should put me at 8.3, which would be about right here. So 8.3 would be 1 standard deviation to the right. And if I go to the left, that would put me around here at 5.7 hours of sleep. That would be minus 1 standard deviation. And when we count by standard deviations like that, so this number -1 and this number +1, those would be z-scores. I mentioned that the other day in class. A z-score counts how many standard deviations something is. Given that I'm assuming this is a normal distribution, then the percent of data I expect to find on average in between 5.7 hours of sleep and 8.3 hours of sleep, I expect about 68% of the population to fall in there. So here to here. Should be about 68% of the data. Now, just a little graphical play on this. If 68% of the data is in the middle, 100 minus 68% is going to give us 32%. And if we take half of 32, that's going to give us 16%. So there's going to be about 16% in each tail. So for example, this tail right here should represent about 16% of the data. And this tail right here should be about 16% of the data. Now, if that's the case, then this score of 5.7, which happens to be one z-score, a z-score of -1 or 1 standard deviation to the left, that means 5.7 has to be the 16th percentile. So P16 in this case, with a mean of 7 and a standard deviation of 1.3, would be that 5.7 hours. So let's check that estimate here based on the empirical rule. The empirical rule is that there's about 68% of the data within one standard deviation of the mean. Again, whenever we talk about standard deviation, we have to bring up the mean. Can't go, standard deviation doesn't exist without the mean. To check that here, to do percentiles, I can use the left tail for a percentile. The percentile always looks for the percent below. And what this is telling me right here, it defaulted to a 2.5% here, right? 0.025 as a decimal would be 2.5 as a percentage. So hours of sleep of about 4.452 per night would put somebody in the about second or third percentile. I was looking for the 16th percentile. Back to as a decimal, 0.6. Here it gives me 5.707. I had called it 5.7, so they're close. So I can either start with a percent and find a number, or I could go the other way. Given a number, I can find the percent. So for example, what percentile would 9 be? So I could just come down here and replace that cutoff with a 9. And then the computer then says, oh, well, if hours of sleep is normally distributed with a mean of 7 and a standard deviation of 1.3, then 9 would be about the 94th percentile. 0.938 as a percent would be 93.8. You can have a fractional percentile, or you could round it up or down, in this case up to 94th percentile, according to that data. So StatCube gives us a pretty slick way to either switch between a percentage to find a value or a value to find its percentile.